What's going on, dudes? Algebra 2 students in the house, all three of you. And this is sad because I have a huge number of Algebra 2 students and I don't know where you guys are at. And so I'm basically going to have to email you guys out and say, what's the deal, yo? Do you not like my facial hair or something? Now, come on, let's talk it out. Talking it helps the process here. So, laugh at me and say, haha, that was funny, or no, that wasn't funny at all. It also kind of helps. You guys can also kind of help me understand whether or not I'm funny, because when I'm not funny, then I just start not making the terrible jokes. But for now, I just keep it up. Anyway, do you guys not like the smell of my breath or something, and that's why you guys don't show up for class? Or and I hate to say it, but again, I'm preaching to the choir because I'm talking to the only three people. Well, there's a few more than three, but I'm talking to the three people that just showed up today. IDK. All right, awesome. Sam, I'm glad you didn't say it's your rank breath, dude. All right. Anyway, I'm going to get on my comfortable seat. We'll get this thing up and running. Whoa. There we go. All right. So check this out. We're going to get started on this thing. We'll see what we got. All right. I just want to try to match up the graphs here. So what I'm trying to do is I'm trying to match, let's see, I'm trying to match this graph to the equation. So we're going to continue to play this game and try to get these things to match up. So take a look at, I think maybe this one would be the best. Let's look at this graph right here. Do you see the one on my mouse? All right. Say yes or no, or I don't know what you're talking about. Yeah, all right, awesome. So you see the graph that I'm talking about here. And what I'm going to ask now is, all right, so we're looking at this graph. What are its our x-intercepts? -1 and +2. Awesome. -1, +2. And these are the what? The x-intercepts? How do I find an x-intercept? Like, what does that mean? It's where the graph does what? It crosses the x-axis. Exactly. All right. Here, I got a better question. It's not necessarily what are my x-intercepts. What I should really ask is, what is the coordinates of the x-intercepts? So this isn't just -1. It's actually two numbers because you're talking about a Cartesian pair. So what are the coordinates? What's the second number I need to write in there? 0. There we go. Awesome. And then over here, I got +2 comma what? 0 again. Awesome. So the thing that's in common between these 2 points right here is the 0, right? It's saying if you want to find the x-intercept, it's on this line. And what's that line? Well, that's the line where the height of that line is equal to 0. Making sense to you? There's a fly in my office. I want to kill it. I think I might. I'm going to try. Well, I'll do it later. Anyway. Alright, so if I want to find the x-intercept, I set y equal to 0, and then I solve for x and I figure out what it is. So let's compare that to these graphs over here. Okay? So now, look at these equations, and which one can you tell me has 0 as your solution? Or not 0 as your solution. Which of these has x-intercepts as -1 or +2. Does that make sense to you? No. Okay. All right. Okay. Here's what I mean. All right. Let's take a look at this equation right here. Let's just try it out. All right. This one right here, k of x. All right. K of x is equal to -x plus 1 times x minus 3. All right? So what it's saying is I want to figure out what x value, or which of these equations, where if I plug in the x value, it will give me y is equal to 0. And I know that you say, hey, wait a second, that's a k. Why are you talking about a y? Well, because we interchange those things. This letter over here changes, but usually we always use x. So in this case, where k equals 0. And I guess in that case, I would graph that as k, and this is x. So anyway, if we plug in x equals negative 1, that makes this thing right here, what does that make this first term? If x equals negative 1, what happens to that first term, the negative 1 plus 1? Negative? Caitlin says negative. I disagree with you. Negative 1 plus 1 is not a negative number. It's going to be 0, right? Big fat goose egg. Does that make sense? Because I plugged in negative 1 into here, and that became negative 1 plus 1, and that became 0, and we all know that that's cool, right? Do you guys agree with me here, or you guys disagree with me? What's your deal? What's going on? All right, awesome. Now, if I plugged in negative 1 into here, into the second one, I'll get negative 4, right? But does that really matter? Does it matter what I'll get for the second one? My question is, did I really need to calculate out that second one? Or do I already know what this is going to equal to? I'll give you a hint. Okay, what is 0 times 4? Or 0 times negative 4? 0. Yeah. So what I'm saying here is it doesn't matter what number this is, because I already know that if I plugged in negative 1 into here, that would make this first thing 0, and no matter what I multiplied by, because this is multiplied and there's actually a negative out in front, but negative times 0 is still 0. So it's basically, I know that this thing is going to equal 0. Are we cool? Yes, awesome. Awesome. So I know that this works. This point right here works with this equation. Do you guys agree? Because I took the negative 1 from the x and I plugged them in here, therefore that equation point works with that equation. This could be, this is a candidate, this equation right here is a candidate for the equation we want to choose. But if it works for this point, we need to make sure it works as well for that point over there. Does this make sense to you? So what I'm going to do is I'm going to try plugging in 2 into here. So now, if I plug in positive 2 into here, what number do I get? If I plug in positive, I get a 3. If I plug in a positive 2 into here, what number do I get? I get a 1. 3 times 1, is that 0? Because what I'm trying to figure out is what do I need to plug in there to make that 0? Three times 1 is not 0. 3 times 1 is 3. Technically, I guess you would have a negative out in front, so technically negative times 3 times 1 is negative 3, but it's not 0. So therefore, this cannot be the equation that we're looking for. Does that make sense? Because if it were the equation that we're looking for, it would have worked for both points, but it only worked for one point, so therefore it cannot be the equation that we're looking for. Now I'll tell you what, take a look at this list on the right, and I'm going to let you have some time, alright? I'm going to let you have some time to think about it, but which one of these equations, and tell me the letter P, K, D, R, which one of these do you think are good candidates to try out to see whether or not it works with this graph? So what I'm trying to do is I'm trying to match the equation to the graph. And we've already figured out that K doesn't work. Okay? Sam, I just said K doesn't work. But it's fine because it was a guess. Alright, so which ones could work? Give me a candidate. We'll try it out. G. Let's see. G. Which one's G? P, Q, R, S. Why don't they put this in order? G. Awesome. Okay. Why did we choose G? Alright, Corey, right? Corey, you chose G. Now, here's what I'm going to say with that. X plus 2, X minus 1. Now, I'm not gonna burn you because you guessed. I love that you guessed, and I want you to always guess. So don't ever feel bad that I'm going to make you guess. I'm going to say that you're wrong, though, off the bat. I like your thought process, though. I think I see what you're thinking. May I take a guess at what you're thinking, and then you can tell me whether or not I'm right or completely wrong. What I'm going to mind read and see if I'm correct here is that you chose G because there's a 2 over here and there's a 1 over here. And you saw that there's a 2 over here and a 1 over here, so therefore you said, hey, wait a second, if I plug in that 2, that might be able to kill it out. Because back when we had K, where we had the first one be X plus 1, try to look at K. See that first thing right there, X plus 1? That worked with this one right here. That worked with that. So you said, hey, well, when I plugged in the 1 into the second term, the 2 over here into the 3, it didn't work. So, all right. So anyway, here's why what you originally chose, Corey, is wrong, though. Okay? If I plug in -1 into here, what do I get? I plug in x equals -1 into this first term. What's that number? -2. No. -1 plus 2 is not -2. We're talking about -1 plus 2. I know, you were just joking around. Yeah, Sam's got it. It's 1, right? And if I plug in -1 into here, the second one, I got -1 minus 1, which is actually -2. So I get it, Corey. You were actually answering the second question. You were thinking ahead of time, right? Right. Anyway. So when you look at that, 1 times -2, actually there's a negative out in front here, because see, there's that extra negative. I know it's probably written very hard to see. That extra negative, you can see it right over here. It says G. There's that extra negative out in front. So technically this is +2. But it's not +2 because I'm trying to look for when this thing equals 0. So therefore this cannot be one of my equations. Now, why did I go through this whole discussion with Corey even though I knew he was wrong? It's because I want you guys to start looking for the patterns to see which equation you want to try guessing next. I want you to look for the patterns, because I agree with Corey. There's a 2 here, there's a -1 there. That could be very advantageous to helping us. What are your thoughts? But Corey chose the ones with the wrong sign. I'm going to let you know now. So I'm going to erase this because this one was wrong. G of x, that was a wrong guess. But it was a good guess, Corey. Alright, we got d of x. Which one's d of x? Okay, Sam, I'm going to say right off the bat, that's wrong. I like that you guessed, though. I think that for me, oh, there's 2 d of x's. Oh, that sucks. What a poor typo. Is this the d of x you're talking about? Yeah, okay. All right. You know what? Let's check it out. Let's see. Let's see. D of x. Now I have a question. Have you learned this stuff before? You should have learned this stuff before, and I want to go through this much quicker than I'm going through it now. You should have learned this stuff before, but if you haven't, that's fine. It's kind of a game, and I'm going through it kind of slow because I want you to figure it out for yourselves. But anyway, let's try it. D of x equals, is that negative 2 times x minus 2 times x plus 1? Awesome. Okay. So if I plug in the negative 1 into this right here, substitute in as x, I've got x negative 1 minus 2. What is that? Negative 1 minus 2. Oh, you're right, I'm sorry. It was hard to see. That was a positive 2. You're right. Okay, but anyway, that first thing is 2. When I plug in the negative 1 in here, I get 3. Or negative 3, excuse me. When I plug in negative 1 into the second one, what happens? Zero. Awesome. Because does it really matter what those first two numbers are? At this point, I would have to say no. Because if the last number is 0, then those first two numbers, it doesn't matter. They could be 1,000,000, they could be 1,000,000,000, but as long as they're some number, if I multiply that by 0, the whole thing is just going to 0 out. Are we cool? I thought you multiplied the inside by the exponents first. There are no exponents on this thing. But sure, go for it, Sam. If you wanted to multiply 2 times negative 3, that would be negative 6, but you multiply it by 0, it still kills it. Is that clear? All right, I'm sorry. Sorry, just playing around. All right. Corey, what I'm doing here is I'm taking a look at a graph. The graph that we're looking at is this one right here. So I drew it right here. By the way, this thing comes up to 1. So it goes, so the points that I can read off this graph is negative 1 comma 0 and 2 comma 0. See? Negative 1 comma 0, 2 comma 0. And I also know that it's going up to 1. Got it? So now what I'm trying to figure out is which of these equations matches up to that graph. And the way that we're taking a look at it is we're focusing in on the x-intercepts. Because we know that in the x-intercepts, the x-intercepts always has the second variable, or the second point, 0. It's negative 1 comma 0, or 2 comma 0. So if we plug in negative 1 for x over here, we want this to be 0. And apparently it works here. If we plug in negative 1, that makes that 0. This whole thing is 0. Does that make sense? Yes, we're trying to get 0 for the answer because that's what we're analyzing here. We're trying to figure out what the x-intercepts are. And whenever we think of x-intercepts, the first thing we think of is the y value is equal to 0. So I have an x-intercept of negative 1, the y value is 0. Or in this case, it's the d value. I mean, we just use the different letter d, but I mean, you could replace that with a y or an f or whatever you want. All right. Now, let's plug in the 2. If I plug in 2 into this equation, does it make one of these 0? If I plug in 2 into this equation, what is my answer? I guess that's the question. It's 0 because if I plug in 2 into here, see this first term, this first part of that multiplication is 0, because 2 minus 2 is 0. So it doesn't matter what this is, which is, by the way, 2 plus 1, which is 3. It doesn't matter what that is, because as long as this first term is 0, you multiply 2 times 0 times 3, it's still going to end up being 0. Does this now make sense to you? We use any coordinate. No, we haven't been using any coordinates. When we took a look at that graph, and I'm looking at this graph in particular, I'm just trying to read off a few points, and I think that on that parabola, there are some points that are really interesting. Those points are -1, 0, +2, 0, and I would call this, give me the coordinates of this point up here. What is the coordinates of this point right here? 0, 1. Now notice how this one ended with zeros, this one ended with a 0, this one started with a 0. Because this right here is called the y-intercept. When you find the y-intercept, you're making the x equal to 0, which is the first number. Does this am I being clear to you now? All right, now we deduced that this equation right here could be our graph. This could be the answer we're looking for. Why don't you check it out? And now you're thinking, like, wait, how am I going to check it out? Remember I told you I'm going to give you a way to cheat. But I want you to be able to check it, your work. I'm fine with it. I want you to understand what's going on. So I want you to take a look at Desmos. Go down to the bottom of your screen, type in, or click on the Desmos. I know I uploaded it to your Google Chromebooks. I'm going to switch over to Desmos. You won't be able to see my computer screen per se, but I want you to type in Desmos. I want you to go down to the graphing calculator. All right. And I'm just going to type it in my web browser. All right, so when I go to Desmos, I want you to put in that equation, exactly what it says. I want you to put in 2 parentheses x minus 2 parentheses x plus 1. Now riddle me this, my friends. Did we get the graph right? That's the graph of that equation. This is the graph of this equation right here. Did we get it right? Did the graph you came out with look exactly like this thing? No. I don't know what your computer screen showed, so describe it for me. All right, Corey. The opening is going the other way. It's pointing down. Okay. Yeah, Sam. Actually, the way I say it's pointing, when I talk about a parabola pointing, I think of how it's opening up. So technically, that graph is opening upwards, whereas the graph that you want is going to open downwards. Okay. All right. So, but we're on to something here. But we're close. We're not too far off. All right? We're really close. So, I hate to say it, but D doesn't work. But it's really close. In fact, how can I make a graph open downwards? What do I have to do to make this graph open downwards instead? Now, I think I went over properties of a parabola. Negative. Make what negative? I would have to make these negative x's instead? Is that what you're saying? No. Now remember, when we have y equals ax squared plus bx plus c, this is the most general equation of a parabola. And remember that a? Do you remember what it does? I think I remember, didn't I show you guys using gummy bears? And I was like, please don't eat me. And I told you what it does, like how the gummy bears like shrink the thing. There we go. Kaylin's on some. All right, wait. Just so I can make sure. Did I show you the gummy bears, or was that a different class? Yeah, you guys were the gummy bear class? All right, good. So this A will change the shape of the parabola. If A is a big number, then that stretches the parabola, or I guess if you want to think of it, it kind of makes it skinny. I think of it as gummy bear. I stretch that parabola out and makes it skinny. Or this A, if it's a fraction, it's a small number, it compresses it down, which kind of makes it a fatter parabola. But I kind of think of it as compressing a gummy bear like this. Now, if A is negative, that went from this to this. You have a happy parabola versus a sad parabola. All right? So now, that kind of tells me that it kind of is up to this number out here. Because if that number right there is positive, then I have a happy parabola. But is this a happy parabola? What I mean by happy is it like a happy face? All right. Ah, I see. So, Sam, you're talking about making a negative out in front. All right. So let's see. What's another suggestion? You said L. Ah, that's a good one. That's a good one. I agree with this. I like where we're going with this. L of x. What that does is it puts a negative out in front. All right? Now I want you guys to get used to the shape of what a parabola looks like. All right? You put a negative out in front, you change that to an L of x, you put it out a negative out in front. Look at Desmos again and tell me if you think that that matches up these graphs right here. Because there's one last check that we need to make. Oh, actually, you know what? I'm going to say L of x is wrong already. Don't do L of x because actually there's a plus here and a minus here. No, we wanted something. We still want something that has a minus here and a plus here. We don't want to change those. What we wanted to do is change this number out in front. Don't use L of x. And I'm actually looking now to see if it actually. If there is a graph that works. Because I don't see it here. Which really stinks. Like, wait, seriously? They didn't give us a graph that works? Minus 2 plus 1. Huh. To be honest with you, I don't necessarily think that any of these graphs really work, but there's one that gets really close. So I'm going to teach you that one. And then I'm going to yell at these people because they did something wrong. What is that? I've never heard that in my life. I'm going to go investigate. I want you guys to think about this, though. All right, I'll tell you what. Let me see what Kevin says. I'll be right back. Hold on. Hey, did you guys hear I was trying to get your help. My team stinks. Alright, anyway, I'm sorry. Yeah, thanks, Sam. You guys did exactly what the other teachers did. They were like, I was like, there's a speaker in my room. It's like speaking right above my head. And they look at me and they're like, you okay? You need help? I'm like, you guys stink. I was trying to like get your help, and yet you guys just tease me. That's what you do, huh? Thanks. Fine. I won't talk to you anyway. All right. Anyway, I don't know what that was. It was weird. All right. Here, check this out. Here's what I'm going to say. I would say that the answer is negative. You put a negative out in front there. You can't see that because that marker sucks. Let's just put a negative out in front there. Because what that does is it keeps our x-intercepts the same spot, but it flips the parabola over. Do you guys hear that, or is that just me? Oh, I see. It's not a speak. It's from you guys. You guys are doing that. You guys are just messing with my head now. All right. Anyway. I'd put a negative out in front because that keeps those x-intercepts in the same spot, but the thing is it flips the parabola upside down. Does that make sense to you? Because of that negative, it flips that parabola upside down. Now, there is no solution up there. Let's make it f of x equals negative x minus 2, x plus 1. I think the closest one they have is a negative 0.5. So I don't actually think that this is actually a good. I mean, I actually think that that's still the wrong. That's going to be the wrong answer. And would you guys like to know how I know it might, why I think it might be the wrong answer? Actually, wait. Let me think about it. You know, it could be. It could be this. It could be 0.5. Here's how I would do it. This equation right here passes the test of the x-intercepts, right? If I plug in negative 1 into here, that makes that one 0, and therefore that whole thing will be 0. Agreed? Yes, awesome. If I plug in positive 2 in here, that makes this one 0, and therefore this entire thing will be 0. So this thing passes our x-intercept test. Actually, now that I think about it, we might be on to the right track. This might actually be our answer, which, by the way, is z of x. All right? Here's what my thoughts are. This third coordinate I can check, and this will help me determine the size, because when we had a 2 out in front, the 2 made it too tall. You see what I mean? It still landed at the correct points, but the parabola went up way taller than we would want it to go. So you could have a parabola that still has the same x-intercepts, but it will have the wrong y-intercept. So a good way to check that is to use the y-intercept. So if we plug in 0 for x, we should get y equals what? 1, exactly. If we plug in 0 for x, we should get y equals 1. Just like if we plug in negative 1 for x, we should get y equals 0. If we plug in positive 2 for x, we should get y equals 0. So if I plug in 0 for x, I'm going to have negative 0.5 times negative 2 plus 1, or times positive 1. All I did was I plugged in a 0 here and a 0 here. Agreed? Alright, awesome. Now when I multiply negative 0.5 times negative 2, that gives me positive 1. Multiply that by positive 1, I get positive 1. Boom! This is the correct equation. I guess I don't have to go and call and beat up somebody for writing down the wrong answer. That's the correct answer. Does that make sense to you? Do you guys see how we logicked our way through this thing? Okay, awesome. It's crazy. All of you guys have your sound off, but the sound's kind of going haywire. Anyway, hey, I'll tell you what. I know I took half an hour. Can I erase this, by the way? You want to write this down? Alright. Finish? Got it? Alright, awesome. Take a picture of it, take a screenshot. I'm going to erase it now. Alright. I took a half hour to do this, and the reason being is because I really want you to know how to do this stuff. But for the most part, here's what we're going to be looking at, alright? Why don't I do another one for you? I'm just going to go through my logic as quickly as I can. Cool? Alright. Let's try this one right here. Problem number 7. Alright? Here's my problem.
Mom, do you have extra notebook? Yeah, so I can write notes. I'm on a web conference. I need to write notes.
Hey, person who's, because I don't actually see who's the person who's asking for a notebook right now. Can you try muting your microphone? Because we can kind of hear you. I mean, that's fine and everything. I like hearing your voice, but I'm just saying. Alright, awesome. Alright, so I'm going to take a look at this graph right here. I'm looking at the graph and it kind of crosses here and crosses over here. So I would say that it crosses at, this is probably -1 and this is +3. I should put a comma 0. Does that make sense to everybody? And then if I were to graph the x-coordinate, that would be 0, -3, or this is the y-intercept in this case. So here's my x-intercept, my y-intercept. Got it? I'm going to tell you right off the bat, I kind of feel like I know what the answer is going to be. I would say the answer is going to look something like this. I think there's going to be a number out in front here. Could be. I don't know. But I would say that my function is going to equal something that looks like this. How do you think that I got that so quickly? What's your thoughts? How do you think that I got this part so quickly? The points on the x, exactly the x coordinates. Yeah, I know. All right, so here's my thoughts. Here's my thought process. See this -1? I want it to go into here, so that makes this thing 0, and that will kill this whole thing when I want to find an x-intercept. I want this +3 to go into here and make that 0 when I plug in that one. So that kind of takes care of those intercepts. I know that this number out in front, I know it's going to be a positive number because the parabola is going to open up. So what I'm going to do is I'm going to take a look at that second page, and I'm going to see which of these would be candidates. Which of these could work? Let's see. I would say, does S of x, Sx, does that work? No. Why not? Because of the -2. I know that the -2 will cause this parabola to open upside down. That's not what I want. Alright? Alright, another thing. Alright, so let's see another one. S of x doesn't work. What about, alright, I'm looking for +1, -3. What about, alright, k of x doesn't work because there's that negative. Someone said q of x. Let's take a look at that. I can't find that one. It's all the way at the bottom. Q of x. Awesome. So the number that they have out in front is really just the number 1. So they don't have any number out in front, which is fine. Let's check to see if this works. The final check we can run this thing through is, does it work for our y-intercept as well? So what we do is we say, all right, we're going to take this, we're going to take 0 and plug it into here, and we should get -3 as our answer. So if I plug in 0 into here, I get 0 plus 1, which is 1. And I get 0 minus 3, which is -3. 1 times -3 is -3. Boom. This is our correct equation. That's on an f of x. That is a q of x. Does that make sense to you? And I hate to say it, but I spent 40 minutes doing the warm-up. But I feel like going through this with you so slowly is actually the best way to teach you this stuff, and I think we can go through the next pages much quicker. All right? So I'm going to move on. I'm not going to give you a break. I'm just going to go straight on. I'll tell you what. Let's see if we can. I think class ends at 10:25 today. Let's see if we can finish 15 minutes early. All right? So I'm going to just keep burning all the way through until I get to 10:10, and then I'm just going to be like, all right, we're done. Sound good to you? All right. I apologize for going so quickly, but anyway, all right. In the last problem set, we learned how the graph of quadratic functions is represented by symbolic and factored form. In this problem set, we learn how to reverse the process. We basically take a graph and we're turning it into a symbolic form. We're trying to match these things up. Now, what they're saying here in this particular part over here is that just figuring out these x-intercepts, I think that they call them, what did they call them? Just figuring out these factors is not going to give you the whole story because of that number out in front that could be there. And that number will change how that parabola looks. It will still cross at that same spot, but it will change. Maybe it will make it more of a real extreme parabola. Or maybe it will make it a very shallow parabola. All of these parabolas will have the same factors, but they look all different, and that will be changed based on this value of a. So you need to be worried about that a. Not worried about it, but just kind of understand. All right. Reflections. If you have two x-intercepts for a quadratic, you can find its symbolic representation. If not, all right. Or yeah, if you have just the x-intercepts of a quadratic of a parabola, can you find the equation? That's my question. If I told you, all right, now draw the parabola that goes through this point and this point. Okay, Sam says yes. I'm going to draw the parabola Sam is thinking of. Sam, is that the parabola you're thinking of? Because that's not the parabola I was thinking of. I was thinking of this parabola. To be honest. So I hate to say it, Sam, but actually the answer is no. We can't just have two x-intercepts and figure out what the parabola is. You need to have a third point, and that third point we usually like to know what is the y-intercept. Now if I told you, hey, I need a parabola that passes through all three of these points, then my parabola would be totally wrong and Sam's parabola would be correct. Or we need to have the vertex is another common point. So if I gave you 3 points and I say I need a parabola that passes through all three of these points, then I have a parabola that you need to match. See what I mean? So you don't need just 2 points, you need 3 points. All right, let's try this one. Find the symbolic representation of a quadratic function with zeros at -3 and -1, and it has an x-intercept of -6. Okay, all right. So here's what we're going to do. We're going to graph this thing. -1, -3. Boom and boom. Got it? And its y-intercept is 0, -6, so somewhere down here. Got it? What do you think that the graph looks like? Well, here. The graph looks something like this. Yeah, it's totally a negative parabola. Let's figure out the equations, f of x. Let's figure out what that's going to equal to. I can tell you a few things about it. I can tell you that it will probably look something like this. There's going to be a parentheses here and parentheses here. What's going to go in this first parentheses and what's going into the second one? You guys tell me. It will have an x and a number over here. What's going in this first parentheses? X minus 1. Whose name starts with an M? Huh. I have no idea who that is. All right. Elijah's saying x plus 3. Kaylin's saying x minus 4. M is saying x minus 1. All right. I agree with Elijah. Because look, if I put in an x plus 3 over here, then this factor right here, that's what we call them, factors. If I plug in the -3 into here, that will make that 0, which is what I want because it's one of my x-intercepts. You see the pattern that we got here? All right, now, Elijah, don't answer. Somebody else answer. What's the second term going to be? What is the second thing going to be? X plus 1. Very good. Because if I plug in the -1 into here, that makes that 0. And if I plug -1 into here, that doesn't make that 0, but it doesn't matter because if that second one is 0, then 0 times whatever this is, even if this were 3 billion, it's not 3 billion, by the way, it's the number 2. But 2 times 0 is still 0. So that's how I'm able to get this part of the equation so quickly. Does that make sense to you? Now, there is a number, and I'm going to call that number A. And I tell you what, I don't know what A is. I can figure it out, and I have a clever way of doing it. What has been the way we've been figuring out whether or not this equation works or not? What is the third coordinate that we turn to? The vertex? All right, we can't really read the vertex in this thing, but I would say this point right here, and it's not the x-intercept, it's called the y-intercept. There we go, exactly. Kaylin, I'm sorry, you said it correctly the first time, I just didn't read that part. Yeah, the y-intercept, exactly. So, Sam, Sam, I'm going to say that you thought, what Sam's referring to is when we have the y equals ax squared plus bx plus c. Is that what you're saying? That the y-intercept used to be the c? Okay. I'm going to say that is actually not accurate. It is for the very simple parabolas, but not for the ones we're doing. That's true, Sam, when we're doing like Algebra 1 stuff. But when we're doing Algebra 2 stuff, that's not always true. And I'll explain to you why. But I think that what you're thinking is this. Y equals mx plus b. Right? This is the equation of a line. This is the equation of a parabola, line. Parabola, line. What's the difference? It's that x squared term. This one has no x squared term. But I see where you're going at, Sam, and tell me if I'm wrong here, but basically what you're saying is that this b is the same as the y-intercept. That's true for lines. For parabolas, that doesn't work all the time. Got it? All right. Now, what we did was we're going to use this point right here. This point is 0, comma, -6. That means if I plug in 0 for x, I'll get -6 out here. So you know what I can do to figure out this a? I got a trick. Well, here, tell me this. Tell me at least if you understand this. Is a going to be a positive number or a negative number? Kaylin and Elijah say negative, and the reason being is because it opens downwards. You can see this parabola obviously opens downwards, so therefore you know that this number out in front has to be a negative number. I think we're all happy with that. So, let's figure out exactly what number it is. I can show you the trick. Here, I'll teach it to you right now. This third point right here, if I plug in x equals 0 here and 0 here, then it should equal this f of x, the value of f should be -6. So I'm going to plug in all that information. I'm going to figure out what a is. -6 is equal to a times 3 times 1. Do you understand what I did there? Make sure you do. Tell me yes or no or IDK. If you don't understand, say IDK and that's fine. I'll just go back and do it. But I mean, if you do understand, that's cool. All right. Now, I'm going to, 3 times 1 is just 3, so I'm just going to get rid of that if that's all right with you. Okay? By the way, that's times, so I'm just going to divide out the 3. So I have a equals to -6 divided by 3, which is -2. Ah, that tells me my equation should have been this. -2. And I'm happy that that became -2 because I knew that it would be negative to begin with. This is the equation of the function that they're describing. Does that make sense to you? Are we happy with that? Awesome. I'll tell you what, I don't even know if this is your homework. Actually, I know it's not. I think your homework starts here. But since Mr. Baldi is such a nice guy, why don't we just go through some of this? I think you start turning in page 6 to whatever. So let's do it. All right? Can I erase this, by the way? Let me know. Take a picture. Does that help? I don't know if that helps. Anyway. All right, take a picture. All right, let's take a look at it. For what intervals does C... okay. For what intervals of C does the graph fx squared plus c have 2 intercepts? Okay. Do you guys understand the question here? Say no if you don't. For what intervals of C does x squared plus c have 2 intercepts? Can you hear my voice still? All right, IDK. All right, good, awesome. What it's asking is this, Kaylin. All right, I'll tell you what. Try graphing. Graph this. Y equals x squared plus 1. Let's try that. Actually, you know what? Let's graph this first. -1. Use Desmos. I'm going to graph it on the side, but I'm not going to go through the pain of showing you my computer screen to do it. So I want you to just use Desmos and graph it. And tell me what are the x-intercepts? That's what I want you to tell me. Actually, you don't even need to tell me what they are. Just tell me how many are there. Is it, well, all right. Elijah, I'm thinking that you got a graph that looks something like this on Desmos. Am I correct? Awesome. And so you said, hey, it crosses the x-intercept twice. Awesome. Good. Good. I agree. Try -2. Try plugging in a -2 instead. Okay? All right. How many intercepts are there? Is there 1 or 2? Okay. It's the same, just tighter. Actually, Elijah, I would disagree with you. I think you're plugging in the -2 here. No, what I meant is x squared minus 2. And I would say that the graph would look something like this. So I would actually argue with you and say it's wider. Yeah, it's just, all I did was just took this thing and moved it lower. So this C, all it is moving it up and down. All right, now let's try this. Y equals x squared plus 1. All right, graph that and tell me, you can graph it in the calculator, you can graph it in your head, tell me how many x-intercepts are there? I just erase the whole thing. None. Exactly, because it's crossing over here, so it never crosses the x-axis, so there's no x-intercepts. So what this question is asking you is, what values of C do I need to plug in order to have 2 x-intercepts? Because if I plug in the wrong value, I can get no intercepts. You don't realize how much you spit when you stand in front of a piece of glass and you realize it's all water droplets all over the place. Which makes you guys think, I'm glad he's an online teacher, not standing in front of me spitting all over me when he talks. Kaylin, what are you asking, negative or positive? I'm not sure which. Oh, okay, I see. There can never be no y-intercept, right? You're absolutely right. I'll never have a parabola that's a function that never crosses the y-intercept. I will, however, have a parabola. I could, however, have a parabola that crosses the x-intercept twice, none, or once. Can you figure out what I need to do to C to make it cross once? I'm just wondering at this point. No. Actually, Kaylin, you're onto something. If I plug in y equals x squared plus 0, or minus 0, it's the same thing, or just y equals x squared, that gives me a parabola that crosses right here. It kisses the x-axis. It just goes, mwah. Exactly. Which basically tells me how many times does it cross the x-axis? Well, it only touches the x-axis once. Does that make sense? Are we cool? You happy with that? All right. So, I think the answer to the first question is all negative numbers. That's what I would say. C can be any negative number. As long as it's a negative number, that will pull this parabola down, giving you 2 intercepts. You guys agree? All right. Number 2. If A were negative, how does that change your answer? Well, if A is negative, then I'm not dealing with a happy parabola. What kind of parabola am I dealing with? A sad one, exactly. It's an upside down one. And if that's the case, what values of C would I need to give me 2 x-intercepts? I would need positive values of C because I would want to push this thing up so it would have at least 2 intercepts. We cool? Awesome. Do you guys see how, since I went through this slowly with you, I feel like you can understand and move faster. Let's keep moving. And I know I only got 8 minutes left. But hey, I'm doing your homework for you, so don't complain. I'm going to graph this. F of x equals -2 x plus 3 x minus 1. And here's where I'm arguing that the time we spent talking about how this graph is going to work is actually really going to help you out. Immediately, just looking at this, is my parabola happy or sad? It's sad because of the negative. All right. Now, is it fat, normal? Or, I mean, is it compressed down? Is it normal, or is it tall and lanky and therefore skinny? Kaylin says it's skinny because of this 2. Got it? Now, where are the x-intercepts? What are the points of my x-intercepts? Give me one of them. 0, 3 and 0, -1. Kaylin, you got close. First of all, if I'm talking about an x-intercept, it has to end with the number 0. It's 3, 0 and -1, 0. Second of all, and you got really close. All right, but that wasn't your. You still have a problem here. You're saying that it crosses here and here. The problem is if you plug in 3 into here, that will make this thing 0. So you're off by a little bit. What do I need to plug in here to make this thing 0? There we go, Melanie. It's -3, 0. Because I'm going to take that -3, I'm going to plug them into here, and that makes that first term 0. And it doesn't matter what the -2 is and the second one is, because if the middle one's 0, and you're multiplying all of these things together, the whole thing's going to be 0. All right? And yes, Melanie, I agree with you. 1, 0 is also your x-coordinate, your x-intercept. So I would say, and you can graph this on Desmos and see if you guys agree, I would say that the parabola looks something like this. So I'll tell you what, go to Desmos, graph it out, tell me what you guys think. But just by looking at this graph without using a graphing calculator, with using your brain, I was able to figure out what that graph is supposed to look like. Now, I admit, I probably didn't get it super accurate, but at least I'm able to kind of like say, it's about here. And that's what's important to me. Not that you get everything super accurate, but that you understand what you're doing. Let's see. Oh gosh. Find the following symbolic representation of the quadratic function to determine both the coordinates of the vertex. Alright. Well, that's what you do. Let's see. What do I want to do with you for that? I'll tell you what. I think that I didn't teach you guys how to figure out what the coordinates of the vertex are. I think it's easy because we can take a look at it and read it off this particular graph. But it might be good for me to show you how to do it just in case these things don't match up exactly. Oh, okay. Well, Sam did it yesterday. Am I covering something that's too old? I know that I'm not going as fast as I want to. I've only got 3 minutes. Solving equations. Yeah, I know. And I thought I pushed everything back so I can give you more time. I think what I'm going to do is, this one's due tomorrow. I think that you should do this tomorrow. And then what I'll do is I'll take the one that's due after that and push it back some more time. Okay? Because I want to get through this stuff, and I'm sorry that I wasn't able to be here on Monday. If I were here on Monday, everything would have worked out. But the reason why I wasn't here on Monday is because I had to go over to Coconut Island, which is one of our lab facilities that we own, and I had to go get our lab equipment, and it kind of was an emergency thing. So, by the way, in the class, I put up our class times, because some of you guys have been emailing me and saying, having questions about that. Fair enough? All right. I think I'm done. I think I feel like you guys hung in there. I appreciate it. I appreciate you. Make sure to come in on Monday next week, and we'll get this party started. But for now, do your best and try to get through this stuff. All right. All right. Also, grade checks are coming up on Friday, so you need to turn in your grades, your stuff, so that I can give you grade checks by Friday. I'm going to try to go through and grade everything tomorrow. All right. Talk to you later. I'm going to stop the archive. Okay, bye.